Okay, so like I said, today we're going to work just a couple problems together, and then you're going to work on the rest for homework tonight. So look at number 2. We are asked what is a reasonable domain and range for this scenario. Water is added to a 30 milliliter solution that is 50% acid. The equation A of x equals 15 over 30 plus x represents the concentration of acid A that's in the mixture as X amount of water is added. Okay, so couple things you might do here. You might look at your graph, okay? And we can also think about that we know what the graph is going to kind of look like. Yeah? So let's think about the domain first. What is the domain asking us for in this problem? Domain's always which variable? X. Okay, what is X in this problem?
Water added.
Yeah, the amount of water added. Okay, now think about that word added. We're only going to be putting in water, right? Could we start with adding no water?
Yeah.
Yeah, could I plug in 0 here?
Yeah.
It's basically the starting value, right? Does 0 make this undefined? No. So at my domain, I'm going to start with 0 with a bracket. Okay, hypothetically, do I ever have to stop adding in water? No. Obviously, realistically, there will be some sort of stopping point, right? But when you're doing these, you can kind of think hypothetically. I'm going to keep adding water until I get up to infinity. Everyone okay with that? Okay. Let's talk about the range now. Okay, I want you to think about this. If I plug in 0 for X, if I add no water, what's the acidity? 1/2 or 50%, right? As I add more water, what happens to the acidity?
It goes down.
It gets less. Does everyone see that? So can you kind of imagine that what's happening here is this part of your graph is doing this, right? What's the highest Y value we reach?
50.
1/2. Because if I plug in 0, that's the biggest this number's ever going to be, right? As I plug in higher x's, this number gets smaller. So my highest number is 1/2. Can I reach 1/2? Yeah. Okay. What happens though as I add more and more water? What's my Y value going to do?
Get closer to 0.
Good. Why is it going to get closer to 0?
Because it's adding more water.
Okay, the denominator's getting bigger. What is the horizontal asymptote of this equation?
Y equals 0.
Y equals 0, because we have a low degree over a high degree, right? So we're approaching y equals 0, and that's why. It's because the denominator is getting bigger, but the top's staying the same. That's why this has a horizontal asymptote of y equals 0. Am I going to reach that horizontal asymptote?
No.
Probably not. So there's my range. Now, looking at the graph would definitely help you here, but it's not necessarily going to give it to you exactly. You have to kind of piece together your knowledge of rational functions with the situation and the graph. Okay with that? Okay, let's look together at number 4, please. Okay, the average speed for the winner of the Indy 500 in 2002 was 25 miles per hour greater than the 2001 winner. In addition, the 2002 winner completed the 500-mile race in 32 minutes faster than the 2001 winner. Okay, if S represents the average speed of the 2001 winner in miles per hour, find the average speed of the 2001 winner. Okay, would you agree this is going to be a distance equals rate times time problem? Okay, and what are kind of the two parts that we're looking at?
2001 and 2002.
Okay. So we're going to look at 2001, and we're going to look at 2002. Everyone okay with that? Okay, let's start with 2001. What is the distance? 500. They say to use S for the speed of 2001. I'm going to go ahead and use R if that's okay with you because my S's and my 5's get confusing. Is that all right with you guys? So I'm going to use my rate times my time. Everyone okay with that? So I'm defining R and T as the 2001 rate and the 2001 time. Yes? Okay. Let's talk about 2002. What is the distance in 2002? Okay. What is the rate in 2002 in terms of R?
That's plus 25.
R plus 25. Good, because the speed increased by 25. Everyone okay with that? Okay. What's the time for 2002? Almost. It's not T minus 32.
T minus 32 over 60.
Very good. T minus 32 over 60. Why do I have to put it over 60? Good. Our speed is in miles per hour, right? So if I put 32, that's implying 32 hours. Everyone okay with that? Okay. Because I had the same distance, do you see that I would want to set these equal to each other? Okay. But do you see that if I set these equal to each other, I would end up with both variables on both sides? Okay, that's a problem, right? We're going to hit a pretty sticky situation there. So think back to your systems days. Remember substitution? We can use substitution to get us down to one variable here. Okay? The variable we're trying to solve for is R, right? So let's replace T. Let's solve this for T. What is T equal to here? 500 over R. So what I'm going to do is I'm going to plug that in right here for T so that I only have one variable. Does that strategy make sense? It would get too complicated if I left both these variables on both sides. Okay. So that means what I'm going to solve here is 500 is equal to R plus 25 times 500 over R minus 32 over 60. Questions on how I got that equation? Okay. Personally, this is one of those times I'm going to go to my calculator. I start distributing this, I'm going to have some weird fractions. Things are going to get kind of dicey. I'm going to have random rationals in the middle. It's going to be ugly. All right. So let's try and enter this 500 in Y1 and this left side or right side in Y2. Being really careful about our fractions. Let me pull up my calculator real quick. And I will do it with you. Alright, so I'm going to get 500 in Y1. Does it matter if you put 500 in Y1 or Y2? No, it doesn't matter. And I'm going to have X plus 25 times. I'm going to do an extra set of parentheses for 500 divided by X. Not positive that you need it. It just makes me feel safer. 32 divided by 60. Could you reduce 32 divided by 60 there? Sure, but do you have to? Okay. I already know that the Y value that I want to hit is really big, right? All the way up at 500. So before I even start, I'm going to go to my window and I'm going to go ahead and increase my Y max to maybe like 600 or 700. And logically, we're finding the speed of a race car, right? It's probably not going to be 10, right? So maybe we make our X max, what do you think? 200? Let's try it. Just a guess to get you started, right? Just a reasonable guess. Let's graph and see how we did. Huh? Not a bad guess, huh? Pretty good. So we're looking for this value, right? Okay, second, calc, 5. Your cursor might show up nice and close. If not, use your X and Y at the bottom. It will tell you where your cursor is. And then you just need enter, enter, enter. So what's our approximate speed rounded to the nearest mile per hour? 141 miles per hour. So what that gives us is what? The rate of what? Good. The speed of the 2001 winner is approximately 141 miles per hour. Questions on that? Okay, you've got the last 15 minutes or so to keep working. This is your homework, okay? So try and get as much done as you can.